Good afternoon, dear colleagues and guests. Let us consider the meeting of Parilina Elena Mikhailovna's dissertation council for defending a thesis submitted for the degree of Doctor of Science in Physics and Mathematics in the specialization Discrete Mathematics and Mathematical Cybernetics on the topic Solutions of Cooperative Stochastic Games with Transferable Payoffs open. According to the order of St. Petersburg State University as of January 11, 2009, number 93/1, I, Zakharov Viktor, Doctor of Science in Physics and Mathematics, Professor at the Department of Mathematical Modeling of Energy Systems at St. Petersburg State University, was appointed Chairman of the Dissertation Council, and let me introduce my fellow members of the Council. Michel Breton, PhD in Physics and Mathematics, University of Montreal, EHC, Montreal Business School. Andrei Garnaev, Doctor of Physics and Mathematics, Professor, St. Petersburg State University. Professor. Gubko Mikhail, Doctor of Physics and Mathematics, Professor of the Russian Academy of Sciences, Deputy Director of the Institute of Management Problems. Vladimir Mazalov, Doctor of Physics and Mathematics, Professor, Institute of Applied Mathematical Research of the Karelian Scientific Center of the Russian Academy of Sciences. Michel Breton is working remotely with us. According to federal law number 127 as of August 23, 1996 on science and the state scientific and technical policy, St. Petersburg State University received the right to independently award scientific degrees. The corresponding order on the procedure for awarding academic degrees at St. Petersburg State University, on the basis of which we conduct our council meeting, was issued on the 1st of September 2016, number 6821/1, hereinafter referred to as the order, and in accordance with this order, the meeting of the Dissertation Council is considered valid if at least 2/3 of the approved participants of the Dissertation Council, but not less than 4 people, take part in its work. Our Dissertation Council consists of 5 members. Everyone is present, including 1 remote member online. She is provided with audiovisual contact. Thus, there is a quorum. I established the following rules for today's meeting of the Dissertation Council with a total duration of not more than 2 hours. First, a brief report by the chairman of the main content of the document submitted by the applicant and their compliance with the established requirements. Questions and answer session, 5 minutes. A brief report of the applicant's scientific degree reflecting the main provisions of the research, 15 minutes. Questions to the applicant based strictly on the report, no more than 2 minutes for one question. No external reviews. Speeches of all members of the Dissertation Council with reviews outlining their positions with questions and suggestions to the dissertation, no more than 10 minutes for the speaker. Speech by the chairman with his review. Answers of the application to questions and comments of the members of the Dissertation Council, not more than 15 minutes. The next is open discussion, speeches at the request of those present at the thesis defense with a brief statement of their positions and or with specific questions and suggestions to the author strictly on the topic of research, no more than 5 minutes for each person. At the same time, all those who wish to, please register in the registration form and introduce yourself before asking. The final answers of the applicant to the questions asked, no more than 5 minutes. Speech by the scientific supervisor of the applicant, no more than 3 minutes. 5-minute discussion before an open vote to reach a conclusion on whether or not to award a degree from St. Petersburg State University to the candidate. For the time being discussed by members of the Dissertation Council, the results of the defense are turned off. Open roll call. Counting of votes by the chairman of the Dissertation Council with the results recorded in the minutes of the meeting. The decision whether to award or not to award the degree of St. Petersburg State University. The final word of the applicant, no more than 2 minutes. Before proceeding to the implementation of the rules of the meeting, I recall the need to turn off mobile phones. Thank you for understanding. I also inform you that the video and audio recording of our meeting is being conducted, as well as the live broadcasting at the website. Simultaneous translation of speeches from Russian into English or from English into Russian is being carried out. So, proceed to the meeting and our first paragraph. Chairman's Summary Report. This is by Parilina Elena Mikhailovna, submitted for the degree of Doctor of Science in Physics and Math, Discrete Mathematics and Mathematical Cybernetics on the topic Solutions of Cooperative Stochastic Games with Transferable Payoffs, was accepted for defense by the order of the Scientific Secretary as of January 11, 2019, number 92/1. The Dissertation Council was approved by the order of the Scientific Secretary as of January 11, 2019, number 92/93/1, and I, dear colleagues and guests, represented it to you already. The applicant submitted the following documents to the Scientific Secretary. First, application addressed to the Rector of St. Petersburg State University, Professor Nikolai Mikhailovich Kropachev, on the acceptance of the thesis for review and defense, filed October 30, 2018. Feedback from Leon Aganesovich Petrosyan, Scientific Consultant, Doctor of Physics and Mathematics, Professor. List of publication from 39 works, which set out the main scientific results of the thesis, including 15 articles published in peer-reviewed scientific publications from the list approved by the Ministry of Education and Science of the Russian Federation. Candidates Diploma of Physics and Mathematics in Specialty Discrete Mathematics and Mathematical Cybernetics, number 017089, dated 16 February 2007, hard copy and e-form of the thesis in Russian and English. The thesis is designed in accordance with the requirements of GOST. The thesis is printed on a copying machine with an indication of the output data according to GOST R7.0.4. It should be noted that all the documents listed correspond to Clause 12 of Section 3, Representation and Defense of the Dissertations of the Procedure of Award of Scientific Degrees at St. Petersburg State University, Appendix number 1 to the order. If there are any questions? Now let us turn to the short report of the applicant. 15 minutes. Thank you, Viktor Vasilievich. I would like to introduce my work, Solutions of Cooperative Stochastic Games with Transferable Payoffs, and my scientific supervisor is Professor Petrosyan. The goal of the thesis is to create a theory of cooperative stochastic games with finite and infinite duration with discounted payoff, as well as the development of the theory of dynamic games played over event trees, in which the stochastic process does not depend on the player's strategies. The aim of the work is also the verification of the principles of stable cooperation, subgame consistency, strongly subgame consistency, strategic stability, and the rational behavior proof condition of classical cooperative solutions in stochastic games. Another goal is the development of methods for regulation of solution to construct subgame consistent solutions based on the imputation distribution procedures proposed in the work. The main tasks: the development of a method determining cooperative versions of stochastic games with finite and infinite duration with finite set of game states, constructing a method for regularization cooperative solutions for such stochastic games based on the imputation distribution, satisfying the principles of subgame consistency of a solution for stochastic games with finite duration of defined on graphs. For the class of stochastic games with finite duration, the problem of constructing a strongly subgame consistent core is also formulated. The regularization of cooperative solutions by constructing some game consistent imputation distribution procedure belonging to these solutions. The implementation of cooperative solution in dynamic requires the verification of satisfaction of the principles of stability, which guarantees the existence of the Nash equilibrium, or in some cases subgame perfect Nash equilibrium. To determine a subgame consistent core based on the imputation distribution procedure in a cooperative stochastic game played over the event tree, constructing a subgame of perfect epsilon equilibrium in a regularized stochastic game, calculating the price of Anarchy for stochastic games, and studying stochastic games played over binary event trees with symmetric players. The development of game theoretic models of data transmission in wireless networks with different configuration using the theory of stochastic games, as well as finding the Nash equilibria and cooperative solutions, the calculation of the cost of cooperation rejection to explain the necessity of coordination of the network participants' actions, to define the game theoretic model of finding stable in dynamics or destable coalition structure using the theory of stochastic games. Chapter 1 was dedicated to cooperative stochastic games with finite duration, where stochastic game with random duration, where Z is an initial vertex of a tree graph, and the possibility that the end will end with Q step. Using Bellman's equation, we determine the value of characteristic function, which is understood as the maximin definition of the game coalition S against the coalition S minus and thus we consider the cooperative stochastic game with random duration constructed on the basis of non-cooperative stochastic game, where we can identify the solution of the game. The key definition for my work is the imputation distribution. That's the number of vertices and the number of pays off to the players, the graphs that can be implemented with cooperative behavior of players. And these pays off have two characteristics: that the sum of vertex complies with the summary pays off when they use cooperative strategies, and the components of imputation coincide with the mathematical expectation of the corresponding components of the imputation distribution procedure with respect to the probability distribution of transitions and termination time of the game. The stochastic game developed in dynamics is the consistency of the solution, and imputation is called some game consistent in cooperative stochastic game is for each vertex, and there exists the imputation distribution procedure. And for every game, the components can be identified as the sum and the mathematical expectation and components of the imputation in subgames, starting with the following vertices of the graph. That's number 7, and for terminal vertices, that's number 8. And let us describe the main results of the first chapter. And that's theorem 1.1. And in case of non-negative functions of a payoff of the initially set game, and also the requirement to non-negative payments made to players according to procedure of distribution of division, the ways of construction of new procedure is offered. The new division in cooperative game with the new characteristic function satisfying properties of positional consistency and non-negativity of the distribution procedure corresponding to it is defined. Theorem 1.2. The theoretical results of the previous paragraph are concretized for the case of Shapley vector and C nucleus chosen as the solution of cooperative stochastic game, and their regularization is carried out. The condition of strong positional stability of the C core is formulated. Sufficient condition of its strong positional stability are obtained. Theorem 1.6 and Theorem 1.6. And as for the main objectives of Chapter 2, viewing cooperative stochastic games with infinite duration, that is to be defined through the finite non-empty set of states, the finite non-empty set of available actions of player, and the action of player in state element, and the finite payoff function for every player and every state, the transition function from state and action profile, and the delta discounting factor. And for the game, you can identify the cooperative solution. That's a set of strategies where you can gain the maximum of the payoff. And the maximum is achieved at many strategies, and we can build a characteristic function of the game, and within this chapter it was built as the minimax and coalition n minus s. And before, it was set out by Shapley in 1953, and we can also achieve it through some stationary strategies. And characteristic function is defined by formula 13, 14, 15, and 16 on the slide. Thus, a cooperative stochastic game corresponding to a stochastic game is a set of any omega. And the main results of Chapter 2, the basic principles of sustainable cooperation in stochastic games of the considered type, which in aggregate are formulated for the first time in Petrosyan and Zinkevich, 2009, including the principle of positional consistency, the principle of strategic stability, the principle of protecting against the irrational behavior of cooperative solutions, are determined. The concept of division distribution procedure is introduced, and the property of the position consistency and the distribution procedure corresponding to it is defined. The method of calculating the components of the position side procedure of division distribution in the explicit form is presented. The method of regularization of the initially given non-cooperative game in order to obtain a positional division is proposed, and sufficient conditions for the strategic sustainability of the cooperative solution have been obtained. And that's the matrix and inequality number 17 on this slide. Sufficient conditions for the strategic sustainability of the cooperative solution have been obtained. That's Theorem 2.5, as well as sufficient condition for the existence of an absolute Nash equilibrium with the same win pays off in the stochastic games. And Theorem 2.6, the principle of protection against irrational behavior is formulated, and sufficient condition for this principle. Conditions of existence of strong transferable equilibrium in a regulated game with cooperative pays off are obtained. Chapter 3 viewed dynamic games played over event trees, where we had the we denote the probability of passing through node, which corresponds to the sum of the probabilities of all scenarios that contain this node. And it is identified for all the players in each non-terminal node of the event trees. the strategies X and the pays-off function that depends on the conditions and strategies of the player. That's the discounted sum of players pays off at the dynamics as you see in number 21 and 22. As for the game, you identify game in the normal form, where the function is set by the condition of the system, and the pays-off depends on X, O, and the strategies U. X, the state of the system, is defined as the solution of the equation number 21 and the realization of U situation. And thus we can define the cooperative strategies that can maximize the sum pays off of the players. That's strategy number 23. And cooperative game is defined by the characteristic function with the gamma approach introduced in 1997 by Chandler and Tolkien, where the definition of characteristic functions for coalition G equals the summary pays off of players of coalition G in the case of Nash equilibrium, when players maximize their pays off. And the main results of the third chapter, the ways of constructing the procedure of division distribution which guarantees the positional consistency of division from the subgame consistent core. That's theorem 3.1. You can see it on the slide, and the equation 24, and for terminal positions that's number 25. The condition of existence of the absolute epsilon equilibrium for an unregulated stochastic game played on the event tree with the pays off equal in the implementation of a set of cooperative strategies. That's theorem 3.2. That's the continuation of the theorem. The conditions of existence of the epsilon equilibrium in the game are found assuming that the pays off of the players are regularized in accordance with the position-based procedure of distribution of division. That's theorem 3.3. The model of dynamic game played on the event tree of random duration is offered, for which the method of construction for the Shapley vector, theorem 3.7, is offered, and also the necessary condition of the existence of Nash equilibrium are resulted, theorem 3.8. The case of the binary tree of events with linear square functions of pays off with symmetric players is considered separately, theorem 3.4, as well as cooperative strategy theorem 3.5. The formula of anarchy price in the described game is obtained. All the theoretical results of chapter 3 are demonstrated on environmental protection models with 3, 4, 6, and 11 periods. Within the chapter 4, applications of stochastic games are viewed. The first part are the stochastic games of data transfer in various configurations of networks. There are several models, and one of the games is viewed with full information and with the lack of information. The configuration of networks is presented in the slide. There are 4 different configurations, and game number 2 is viewed with the full information and with the lack of information. For all the games presented, there is Nash equilibrium, cooperative solutions, and price of anarchy. Joint package transmission game is identified Nash equilibrium through theorem 4.1. For maximum access game, it's theorem 4.2. And for the rest of the game, there are methods of solutions. For example, multiple access with the lack of information. There are functions of pays off and the summary of the pays off. And for this game, there is Nash equilibrium, the worst one, and the cooperative solution, and the price of anarchy is calculated. That is something 23.538. And thus it tells us that it is necessary to coordinate the player's activity and forward and transmit algorithm. And it is shown the algorithm of finding a solution of a cooperative stochastic game. And here we describe the steps of finding a solution of a stochastic game for the network represented. And there were some other applications. We put forward the dynamic model of finding stable coalition structures as solutions of stochastic games of a special kind is offered the work of the algorithm of finding stable coalition structures, three-persons games for two cases with super-additive and non-super-additive characteristic function is demonstrated by numerical examples. The model of the stochastic game Prisoner's Dilemma of two persons with two possible states and unknown player discount factor is proposed. The game has two phases, educational and cooperative. In the learning phase of the game of the player's strategies are Markovian. The conditions of existence of partially Markovian absolute Bayesian equilibrium are obtained, at which in the second phase of the game full or partial cooperation is realized. The case is considered when the training phase lasts one period, as well as when the training phase has an undefined duration. I would like to highlight that I have published 39 scientific papers and 15 articles published in the peer-reviewed journals such as the Mathematical Theory and its Appliances, European Journal of Operational Research, Automatica, Operations Research Letters, Theory and Decision, International Game Theory Review, Automation and Remote Control. In the following 3 slides, the main publications are presented, and as for the approbation of results, the diffusion, I participated in more than 30 conferences, and I would like to highlight the Game Theory and Management Annual Conference, the tasks of optimal stops and stochastic management, the 15th, 16th, 18th International Symposium on Dynamic Games and Applications, the 9th and 10th International ISDG workshops, and the seminars at the Department of Mathematical Game Theory and Statistical Solutions, St. Petersburg State University, and the Department of Dynamic Systems at Krasovsky Russian Academy of Science, at the Trapeznikov Institute and the Institutes of Padua and Sindau and Girard Scientific Center. I was supported by 10 grants and 8 grants, 7 grants from our FFI, 1 grant from St. Petersburg State University, and 1 grant from the Scientific Research Center. Thank you. If there are any questions, or maybe our guests have any questions. Thank you. Now I would like to turn to the reviews, including the external reviews. There were no external reviews, so let us move to the next step. That's the council members. Are there any priorities on the order of your talks, maybe? So I would like to give the floor to Michel Breton, PhD in Physics and Mathematics, University of Montreal, HEC Business School. Michel, please, you're welcome.
Thank you, Dr. Zakharov.
Спасибо большое, доктор Захаров.
Is there still a moment where I ask questions or make remarks on the thesis?
Нет, это Это не вопросы, уже просто выступление.
Well, it's not the questions, it's your report as the council member.
Oh,
Или если у вас есть вопрос, можно задать.
But if you have a question, you can ask it as well.
okay, I will comment on the thesis in that case. I found the contribution of the research to be important and relevant. I found that even if it's difficult mathematical problems, the thesis offers relevant applications and timely questions, and that the problems that are studied by the candidate are important, particularly the environmental problems. And what I found most impressive is that the thesis, which is based on the results of 39 publications, as stated by the author, is an impressive work. It's impressive to put together all these results in a unified format, and it reads very well. I think that the thesis was diffused in important research outlet, well-known journals, many conferences, and that the candidate has published a lot of many papers and has made important contribution to research. So in my opinion, the thesis presented by Dr. Parilina is excellent, and in my opinion, it meets the requirement for the degree. Thank you.
Спасибо большое. Елена Михайловна, комментарии и ответы на замечания, если они там содержатся, может быть, в конце тогда сделаем, после выступления членов Совета. Хорошо? Спасибо.
Thank you. Now I would like to give the floor to Andrei Garnaev, Doctor of Physics and Mathematics, Professor at St. Petersburg State University. Thank you. I won't read my review in details. I would like to outline only the basic moments that I was impressed the most. First of all, the work consists of two parts, a huge theoretical part and practical part, and both of them are of vital importance. The theoretical part identifies the new concepts for the stochastic game solutions, and what is the most important, these chapters are focused upon the cooperation and finding solutions in order to find sustainable cooperation and keeping it in dynamics as well as it happens in the real life. The work, as I have said, is of a large volume, almost 350 pages, and it contains 4 different chapters, and all of them were interesting, but chapter 4, the practical appliances, was the most important for me because I work in the practical approach, and that's why it was very interesting for me how it works with the wireless connections, and that's why it was very interesting for me to read this part of work. And the results from my point of view are very relevant. I can't see any mathematical errors. All the points are quite correct, and I would like to underline that in the work there is sufficient and necessary basis for sustainable cooperation, the necessary basis for sustainable cooperation. And I was interested in reading chapter 4, as I have already mentioned. And what was interesting, even for the classical model of Cournot, it was able to achieve some new results, though this is a very long-lasting model, and the work was widely presented at various conferences and published in many journals, and thus it was reachable for the scientific community. As for the remarks and comments, I think that they do not contain any serious shortcoming. I mentioned 3 comments. That the first 3 chapters of the work suggest that the core is not empty. In the process of building a strongly positivist core, it would be useful to bring the conditions for the parameters of the games under which this condition is met. And then as for Chapter 4 discusses data transmission models and wireless networks, but networks that demonstrate solutions to problems have a simple configuration, contain 3 or 4 vertices. And the rest I don't even want to read because they are so minor. And as I have already mentioned, these remarks are not fundamental and they do not affect the overall high evaluation of the thesis. And in conclusion, I think that the thesis of Elena Mikhailovna Parilina submitted for the degree of Doctor of Physics and Mathematics is a valid scientific work, that the author I introduced new scientific models, and this is a scientific achievement and it complies with the basic requirements established by St. Petersburg State University. Thank you. Now, let us give the floor to Mikhail Gubko, Doctor of Physics and Math, Professor of the Russian Academy of Sciences, Trapeznikov Institute Deputy Head. Thank you. First of all, I would like to say that I was deeply impressed by the dissertation and the introduction of the applicant, and I can see that you have a very deep experience of participating in conferences, and I can see that you are very elaborate in this, and your thesis is a very large volume. It contains 329 pages in the Russian text, and it is one of the longest dissertations in math that I have ever read in my life. It's a doctor's thesis, and it is also filled and packed with the results, several lots of theorems, and it is very consistent and precise. And I won't dwell upon my review, especially describing the parts of the work, because we have all just listened to that. I would like to identify some moments that impressed me the most. For example, the material of Chapter 2, where you view the Shapley value introduced in 1953, and it is still very acute direction of research, because in the past decades these models are being revitalized. They are now studied by the researchers, and they are called now Markovian games as the Markov decision process. So it is very actively used in learning, and this is very hot topic, and all the results in this sphere is to be welcomed, and I'm happy that we have such results in our country. And in Chapter Number 3, one of the most impressive results, the analytical solution of the game, of a very serious game with 2 symmetric players. That is to say, for the theory of dynamic games, it is very difficult to obtain such analytical solution, and that's the cornerstone for studying the applied models as for the environment and financial markets, and the cases that can be frameworked in this model and the management tasks as well. As for my genesis, and I am interested in the management tasks, that's why I have this perspective from the management sphere, from cybernetics, and thus I have some suggestions. I cannot call it a remark or a shortcoming, it's just my suggestion from the position of the theory of games theory, but I have the position of some normative models, how to achieve certain goals, and that's why I think that this dissertation can become a basis for developing the normative approach in the stochastic and dynamic differential games, that is to build those concepts, those solutions, and design and synthesize those concepts that would have a set of certain properties and comply with certain axioms. And I think that is the field to be developed, and that can be the result of your research work, and I was looking for that, and I was always happy reading the work and finding it, but I think that it is necessary to develop it in a systemic way, and it is clear. I would like to highlight it once again, and this is my subjective view. I understand the logic of the dissertation, how it contains all these chapters, but I think that there are minor shortcomings that I think as of the presentation of the material, it would make the reading easier, and thus it can broaden the number of people who can read this, and it can be published as a monography if it hadn't been done yet. I think we should plan that, and from this point of view, I think that it is necessary to add some systemic approach. That is first of all, it's a doctor's dissertation, and that's why you should have your priority in certain fields where you fence some areas and you say, I'm the leader in this sphere, I'm the main scientist in this sphere. And thus it is necessary to formulate a certain task for yourself. And everything that I say, that's the case of my scientific task, and I didn't see this in the work. You can at least formulate this, and the reader can understand the cases that are going to be viewed further on, why the attention is narrowed at certain models, and that would make it easier to describe the cooperation between these models, how they can work with one another. And I think that the models from the third chapter can be narrowed to the models from the first chapter, right? But this issue was not viewed in the work. And there was a wonderful table in your report in the applied part where you had all the results, and it was shown that there are certain cases and certain options, and the table was filled what is done in each of parts of the table. And as for the theoretical part, I would like to see the same table in the theoretical part. And that's why you could have seen all the work done in one slide. So these are just minor remarks. There are some smaller remarks as well. I would like to skip them at the moment. If Elena Mikhailovna wants, I can read them later. As for the text, I have 27 small remarks, and these are some remarks on orthography and spelling and English proofreading, and you should take that into account if you want to publish that in the form of a monography. And but these remarks, they do not affect the scientific novelty and significance, and I would like to say that Elena Mikhailovna is to be awarded with a degree of Doctor of Physics and Mathematics. And now I would like to give the floor to our next speaker, Professor Mazalov, head of Applied Mathematics Institute of Karelian Research Center, Russian Academy of Sciences. And one more remark. I would like to say that for everyone present and those who are watching online, all the reviews are published at the university website, so you can introduce yourself to the reviews. You can do this online at the moment, and all the council members, they know everything about the remarks of their colleagues. Please take that into account. Thank you for introduction. I would like to say that for me, this dissertation is of great importance. I have known Elena Mikhailovna for a long time, and I've been following her work for a long time, and I appreciate the results that she obtained during her research. And it seems to me that she obtained very important results, and the work is dedicated to the vital problem. And she takes into account the stochastic games and solutions, and thus it gives the floor to providing more productive results. She has lots of participations in conferences, and she has lots of publications, and I would like to highlight that there are a lot of Nobel Prizes awarded in this direction exactly, and the applied tasks that are viewed in the work that are vital, and they can be used in data transmission, in wireless connections, and environmental problem programs. And as for the main strategies, the author creates the model with many participants in order to maximize the summary pays off. The system has infinite and finite durability, discounting players, and we are mostly interested in dynamic games, and in order to take into account the interest of the game players. The work is accentuated upon the cooperative games that is vital, taking into account the international sphere taking place in today's work. And the work is quite novel, because everything described in this work, and I can say that the work is very concentrated and structured, and from the methodical point of view as well. And the methods of constructing a cooperative stochastic game with finite and infinite duration are quite original, and thus the given research allows to expand essentially a class of considered problems in a cooperative statement, and the application of stochastic game theory to finding stable coalition structures, modeling of data transfer processes in networks of simple configurations, and also modeling of cooperative and conflict behavior of the problem in environmental protection problems can be considered original, and the validity and authenticity authenticity of the work is determined by the strict mathematical proof of the statement formulated in the work and the approbation of the results presented at numerous conferences and publications, and the thesis is an in-depth scientific work and is important for the development. The main achievement of the dissertation is the development of a new direction in this field, cooperative stochastic games. And it is the first time, I think, in Russia that we can say this. The author proposes an original statement of the problem, developed a mathematical apparatus to find solutions to such games, formulated the problems of positional and strong positional consistency, stable cooperation of this class of game. As an illustration of theoretical results, the author considers and solves applied problems in the field of environmental economics, joint management, and of harmful emission. All this is of great practical importance. The work has 4 chapters, and the first chapter is dedicated to the study of stochastic game of finite duration defined on the graphs. The model of cooperative stochastic game is constructed. The problem of positional consistency of cooperative principles of optimality is studied, as well as the ways of regularization of stochastic games with the use of the procedure of distribution of sharing is offered. And the second chapter considers the class of stochastic games of infinite duration with a finite set of states and strategies of players in these states. The way of building a cooperative variant of the game is offered. Cooperative solutions are defined. The problem of positional consistency and strong positional consistency of cooperative principles of optimality is studied in detail. Conditions of performance, including strategic stability and protection from irrational behavior, are received. The third chapter is devoted to the study of dynamic games played on the trees event, and this class of games has a wide range of applications, and trees and everything can be achieved in an analytical way, and it is to be applied in modeling dynamic processes in economics, environmental protection, and other fields where random factors can influence the development of the system. Regularization of the subgame consistent core in order to satisfy the property of positional consistency of the deletions from this solution is carried out. Conditions of existence of epsilon equilibria in the unregulated and regulated game with the help of the procedure of distribution of deletion and received. The cases of the game with a random end time for which positionally Shapley value vector is built. The game played on the binary event trees with identical players for which the Nash equilibrium and cooperative strategies of players are explicitly found, are calculated. The price of Anarchy is calculated. The work is performed at a high scientific level, and it has a very logical presentation, but still there are some remarks. In the first chapter, in the study of cooperative stochastic games and everywhere else, it is assumed that the players use a fixed procedure of sharing the pays off. The question, what will happen if the distribution design changes? In a number of models, the price of Anarchy is calculated, which evaluates the cost of the system in a cooperative and competitive way. Chapter 3, page 178, in the environmental protection model, it is not clear how to use this concept. In Chapter 4, this characteristic is found for the 3 players, and here the price of Anarchy is determined by the parameters of the task, and thus you can devote some time to analyze this assessment. In a stochastic game involving players wandering through coalition structures, in Chapter 4, there is a balance in stationary strategies. There is no method to find it. We can consider an example for 3 players in which, in this simple case, there are 3,125 different transition matrices, 1,259,712 situations and pure strategies. The paper does not say anything about the complexity of the proposed algorithm for the procedure of distribution of division for finding equilibrium in stationary mixed strategies, and there are small remarks. The formula does not define the parameter, and the price of anarchy is used, which is defined only in the next chapter, though the results obtained in the dissertation work by Elena Parilina represent a scientific achievement in the theory of stochastic games, and the results are published in 39 scientific works and 15 articles in peer-reviewed international journals registered in Web of Science and Scopus, and results were discussed at the seminar of our institute. And I can say that the dissertation by Elena Parilina named Solutions of Cooperative Stochastic Games with Transferable Payoffs, and it corresponds and complies with the main requirements established by the Order on the Procedure of Awarding of Academic Degrees at St. Petersburg State University. And the author, Parilina Elena Mikhailovna, deserves to be awarded the scientific degree of Doctor of Physical and Mathematical Sciences in the specialty Discrete Mathematics and Mathematical Cybernetics. Thank you. And the final review is mine. I would like to say that when I first saw Elena's presentation at an international conference, I was struck by her mature assessment of the field that she was giving a speech about, and very precise formulation of tasks. And for such a young back then, she was very young, and she was a young researcher, and it is very rare nowadays that you can feel her qualification and how she is self-consistent in gaining new knowledge. And this dissertation, which is dedicated to a very serious development of the theory of stochastic games and parameters, including manageable parameters. It is a very difficult task, and Vladimir Viktorovich has mentioned some of my remarks already, and this focused character on the building the theory of dynamic and stochastic games. It is a very important field for researchers. And I'd like to mention that while solving the tasks, finding cooperative solutions in stochastic systems, the vital is the application of these solutions in dynamics, and this transfer was very difficult, and here it is even much more difficult than usually. And referring to the main results that are presented, I can say that in the first chapter it is connected with the issues as for the finite tree graphs, and the functional equations are introduced, which are quite novel. The positional inconsistency is solved, and it is used for the multiple solution of a cooperative game. As for chapter 2, I can say the sustainable cooperation formulation principles, and these principles are known, they were presented. in the works of Leona Ganesevich, the scientific supervisor, and Mr. Zienkiewicz and Mr. Young, many researchers. And here we talk about the complication of the process, because we review the influence of the undefined that can lead to the sustainable cooperation. And the third chapter describes the results that have a significant contribution to the development of the theory of dynamic games played on the event trees, for which the stochastic dynamic processes is defined initially and does not depend on the strategies of players. The model of dynamic play on the event trees is formalized. The class of S-adaptive strategies is defined, and the conclusion of the main functional equations for finding equilibria and cooperative strategies. This problem is well known, but it is getting more complex in the situations described. Chapter 4 is dedicated, as it has been mentioned, the application of the theory for applied solutions. It's a wide range of applications, and it can give us the highlights of what we can do in order to advance the theory, the practical approaches, and what are the problems, what are the hurdles that we can see at the implementation process of the methods. The scientific novelty and theoretical significance of the thesis work consist in the building the mathematical theory of cooperative stochastic games of finite and infinite duration, finding the conditions to support stable cooperation in stochastic games, development of the theory of dynamic games played on the event trees. The practical significance lies in building cooperative solutions and testing their stability in the dynamics on environmental, economics, and information transfer in telecommunication network. I found no major drawbacks. And there are no huge shortcomings. I have formulated several remarks. For example, Chapter 1 describes a class of strategies of behavior in stochastic games, taking into account the history of possible situation of balance in the previous vertices of the tree graph. The author suggests finding solution in this class of strategies, which is a complex and difficult to implement computational task, even with the finite set of admissible strategies. Vladimir Viktorovich has already mentioned the numbers, and we get into the random position with lots of options that are very difficult to obtain without using the big computational effort, and thus it is to be developed in the future, I guess. My second remark is that at page 34-35, there are possible approaches to defining the characteristic functions in stochastic games are described. However, there is no discussion of the practical feasibility of these approaches in calculating the values of characteristic functions with a sufficiently large, albeit ultimately large number of players. And here, that's why it is necessary to identify the effective approaches in order to implement the approaches and ideas that were presented in the dissertation. Chapter 4 discusses gaming data transmission models in communication networks in a fairly simple configuration. Andrei Yurievich, you have already mentioned that there are very simplistic approaches They are simple, and there are lots of many more complex models, and it would be great to obtain some results. And thus, once again, it depends on how it can be applied. And there are some typos and repetitive definitions in the paper, and the remarks made, they do not reduce the scientific and practical importance of the work, and it is a completed scientific study. The results of the research of the class of stochastic games of finite and infinite duration make a significant contribution to the development of the theory of dynamic cooperative games, and it's an important component of a new direction of this theory. The theory of the stochastic cooperative game and the work is highly commendable. The results of the dissertation work have been published in 39 scientific papers, including 15 articles, and in the international scientometric databases, Automatica and European Journal of Operational Research, and she has participated at more than 20 international conferences of high level. And we can see that she is experienced at presenting her thesis while reporting, and the results of the research were supported by more than 10 grants. And the dissertation by Parilina Elena Mikhailovna, Solutions of Cooperative Stochastic Games with Transferable Payoffs, complies with the main regulations of the order as of September 1st, 2016, on the award of degrees in St. Petersburg State University, and the applicant Parilina Elena Mikhailovna is to be awarded a degree of Doctor of Physics and Mathematics in the specialization Discrete Mathematics and Mathematical Cybernetics. All the reviews were read, and the next step is the general commentary of the applicant, where you can comment on the remarks and suggestions and interventions that you have found in the council members' reports. Thank you, council members, for your work, for preliminary reading of my dissertation and formulation of remarks, and let me answer all the remarks that were presented. So first, comments of Andrei Garnaev. As for the subgame consistence and the emptiness is necessary, required in any subgame of the cooperative subtree, since each vertex of the tree in the first and third chapters and in each state in the second chapter has an arbitrary game of n persons, as well as such game parameters as discount factors and transition probabilities, which are also arbitrary. The conditions of emptiness from the core would look cumbersome, so the work was not given. It is possible to use the criteria introduced by Bondareva and Shepley. As for the number of vertices, and the game can be described using a stochastic approach suggested in the paper, but finding a Nash balance in such a game with asymmetric players is a complex computational task. That's why we've used the examples for the set class of game. And I agree with the remark on typos. As of the comments by Mikhail Vladimirovich Gutko, maybe I can only address the major comments, maybe some of them that you're not agree with. No, I agree with all the comments. As for the first remark on different approaches, and chapter 1 describes different approaches to the construction of the characteristic function in the initially given non-cooperative game, and this shows the ambiguity in the definition of the cooperative game, because when choosing the approach, it seems to me that one should take into account the specifics of the game in case the applied problem is considered. As for the connectivity. Insufficient attention is paid to the description of the relationship between the models. I agree with the remark. The model can be described as a special case of Chapter 1. As for the systemic approach, I formulated them in the dynamics of gaining my results with the dynamic of 16 years working at my dissertation, and the structure of work was formed based on that. And as for I can agree with the remarks that there is lack of concepts overviewed, the concepts of cooperative games, but it was not my task. I was aimed at modeling the cooperative games, and we can use the following statistic models. And as for the guide to the work, I can agree. And some minor remarks, I can present you my comments in the written form. As for Mr. Mazalov, the first remark on how we use a fixed sharing procedure. I agree with the remark. This question can be investigated in further work. If the principle of optimality changes in the course of the game, it is out of the question its potential consistency, but such assumption can define a new procedure of distribution of the initially chosen division. As for the second remark, where the price of anarchy is calculated through the payoff of one of the identical players in cooperation and in the Nash equilibrium, I agree with the second part of the remark, and the game, the multiple access, and the formula, it was the general formula for calculation the price of anarchy. As for the stochastic game involving players wandering through coalition structure, there is a balance in stationary strategies with finite number of strategies, and in order to solve the algorithm, and they are based at various procedures. As for the complexity of the algorithms, well, we didn't calculate the complexity, and as everything is focused on using the Lemke-Hausen algorithms, and the complexity of algorithm is already calculated for that, and I can agree with all the typos. And now, as for Viktor Vasilievich Zakharov, as for the first remark about the complexity of the class of strategies chosen, and in the work it is supposed that we view it from the strategies of behavior, and while forming the cooperative strategy, we have coalition and anti-coalition in the class of strategy. And the complexity is using the method of Lemke-Hausen and the procedure of Trossen, and the necessity to define the strategies of behavior when we have some players who do not follow the cooperative behavior, and I can agree that this is very complex. And as for the second remark, the characteristic functions, I do not describe the practical application. In this part, I showed various approaches to cooperative games, and you can use various approaches, and I think it is necessary to pay attention toward the context of the tasks where you build the model, and the complexity of the algorithms, the number of calculation necessary. As for the communication networks, they are too simplistic. I can agree with this remark. With models with a small number of vertices, the method was shown, and the models can be used for a bigger number of players. But the metrics of transmission and the Nash equilibrium will take huge computational power and the programs to be written, and I can agree with the typos as well. Thank you. If there are any other questions towards the applicant, I have a question. Maybe it can somehow be related to what we discussed now, because nowadays in the world there are lots of actions of various agents of influence, the economy and politics, and it is of dynamic character. Do you think, can we formalize these processes in economic strategies, and maybe we can apply the strategies that you have discussed? Maybe this can be the practical application of your work. Thank you for the question. I do have the models of using the Markosian games in order to formulate the models of agents in social networks, but the results are not presented here. But the Markosian processes, the controlled processes, are used while constructing these models, and this is to be developed in the future, and we can use the results, we can apply them in order to find the solutions. Thank you. And the presentations of the audience present, non-members of the Dissertation Council, if anyone would like to present, please introduce yourself and fill in the registration form. Unfortunately, there is no sound in the microphone. My name is Chistякov Sergei Vladimirovich. I'm professor at the Department of Mathematical Game Theory and Stochastic Solutions at our university, Doctor of Physics and Math. And with the old procedure, it was supposed to be a discussion, and I don't know whether I can consider this a part of the discussion, because we have a new type of procedure, and it is necessary to register now, and probably I have some remarks, but I haven't been registered yet. And as for the dissertation itself, I know Elena Mikhailovna, I have known her for a long time, and she is a very respected person. And she's an associate professor from now on, and I can support her dissertation. And I do have some questions, and I think as for the procedure, there are some ambiguities and some shortcomings of the defense, because we used to have previous regulations and we were not restricted by 2 hours. And as for the new rules, I was present at the defense in France, and they allocate much more time for the defense procedure, and they have longer dialogues with each of the Dissertation Council members. And one comment on the procedure and a question. As for the council members, you were given the materials on defense. I cannot see them, and it's very difficult for me to participate in the process, and I think it is necessary to make it more transparent, more public. As for the questions, I think that some notions were not introduced, were not mentioned. For example, the price of anarchy. And what is anarchy? The price, it's the second point to discuss, and I think it is quite acute issue. What do you understand under the notion of anarchy? It's a mathematical term, and what is the definition of this term? What is the content of this term? Well, I would like to hear the definition. I read Shapley's work in 1971, and in 1990s, as for the procedure of the defense, I have expressed my views. Probably you can explain what's that further on. I have lots of these small questions and minor remarks. As for the regularization, what's the purpose? What's the necessity of this regularization? Why do we need to regulate something? And when we don't need to regulate, what are the cases for that? Well, it's something that comes to my mind, which hasn't slipped my mind yet. Thank you. I think that the organizers can take into account all the comments mentioned of providing with the materials and creating more transparency and publicity. And as for the modern state, we receive all the materials online, and all the reviews and the dissertation in 2 languages is published in the internet, and it is open access. You can refer to it. As for the price of anarchy, as it was already mentioned, it's a mathematical term. It is defined for the game, and it equals the ratio. As we talk about the maximization, it's the ratio between the pace of between the games in cooperative strategy and the Nash equilibrium. So it shows how the payoff can grow in comparison with the worst Nash equilibrium in terms of payoffs. And all the players, if they do not cooperate, they achieve the worst payoff. And that is what anarchy is about. As for the regularization, when we need it and when we don't need them, we need them in order to obtain the positionally consistent solution, and within the whole implementation of cooperative strategies in every sub-game, we can achieve the same imputation distribution belonging to the same principle. As for the Shapley vector, we want in every game to distribute the payoff according to Shapley vector, and that's why we can implement regularization in this case, and we can also use it in some other under some other conditions. Thank you. Thank you. Now I would like to give the floor to the scientific consultant, Mr. Petrosyan. Please, you're welcome. Dear council members, what I want to say, first of all, stochastic games are very close to differential games. Why? Because differential games, they transfer from one condition to another depending the conditions of players and the strategies they choose. The same happens in stochastic games, and And that's why when I faced the stochastic games, the n number of persons, it came to my mind that the same problem that emerged in the virtual differential games can emerge in stochastic games. And that's why I thought that probably we can review the stability and the time factor, and that's why it is necessary to introduce the imputation distribution. And 20 years ago, I realized that it was a very serious direction, and back then I thought that it was necessary to have a very talented researcher who can develop this. And Elena Mikhailovna Parilina, back then she was still a student, and this she was given this direction, and she developed and advanced this area. And you remember that in the Soviet times it was said that when they give you a scientific degree, a doctoral degree, it was given the award, the new direction in science. And here I can say that this is a new direction in the game theory. And I can add that besides the fact that the applicant advanced his work, she's a wonderful associate professor at the faculty, and she was the head of the methodological committee. And our department is the largest at the university, and she was brilliant doing that. And there are lots of other current moments that are solved in an operational way by Elena Mikhailovna, and I would like to support her, and I would like you to vote for the award. Thank you. And thus we are done with the presentations and interventions of all the council members, and now I would like to shift to the discussion. And I ask you to turn off the sound at the meeting's broadcast at this time, and those who are not members of the Dissertation Council, I would like you to leave the room, and I will invite you when the meeting is over.
Some remarks about procedure.
No, I find the procedure very interesting. Very. Presentation, we ask people like questions, like what they are going to do in the future and what are the different possible new directions.
Okay.
This may be interesting.
Thank you.
Thank you. Thank you, Michelle. And now let us continue our meeting. Please turn on the audio of the meeting and make sure that the broadcasting works. And I raised the question of awarding a degree to an open roll call vote. I remind you that the decision of the Dissertation Council on awarding an academic degree is considered positive if more than half, but not less than 3 members of the Dissertation Council who participated in the meeting voted for it, according to paragraph 23 of the Order of Awarding Academic Degrees in St. Petersburg State University. So, Michelle Breton,
Yes,
do you vote for awarding a degree?
I do. I vote for.
For. Okay.
Thank you. Andrei Yurievich Garnaev, your opinion, for. Mikhail Gubko, for. Mazalov Vladimir, for. Zakharov Viktor, for. So, unanimously, the decision was made to award the degree of Doctor of Science in Physics and Mathematics to Elena Parilina. We congratulate you. And thus, in the formal way, I would like to say that voted for. 5 people voted against, no. Abstained, no. Thus, the decision was made. Now I would like to give the floor for the final word of the applicant. And first of all, I would like to thank my scientific supervisor and scientific consultant, and we have been working together for 19 years already. And since the moment on, I would like to appreciate for the topic that you given to me and for every help, all-around help in everything within all these 19 years. And I would like to thank Professor George Zakor for the fruitful cooperation and scientific discussions. And I would like to thank the Dissertation Council and the chairman for very attentive character of your work and that you were able to arrive here. Thank you, Michelle, for being with us remotely, and I would like to thank my family first of all. It is partially here, and only they know how much time I spent on working at the dissertation, and I would like to thank all the members of the department for our mutual work. Thank you. Thank you. Thank you. The meeting is declared closed. Thank you all for participating. Please disable the live broadcast of the meeting.